So our next presentation is entitled Response of Groundnuts to Rhizobia Seed Inoculation, Inorganic Fertilizer Application, and Plant Density. And our presenter is Precious Mtengezo. And I apologize if I've messed your name up, but thank you for being with us this morning. And it's all you.
Yeah, that's okay. Yeah, my name is Precious Mtengezo, and thank you for allowing me to be part of this presentation. I'll be presenting on the research title, Response of Groundnuts to Rhizobia Seed Inoculation, Inorganic Fertilizer Application, and Plant Density. And on a research that I'm being supervised by Dr. Muhango and Dr. Rick Brandenberg. Next. Yeah, in this presentation, I'll take you through introduction, objectives, up to the results and discussion and acknowledgements. Next. Groundnuts, scientifically pronounced as Arachis hypoki, is one of the legume crops and which is important for food, cash, and for soil improvement. According to Malawi considers groundnut as one of the alternatives to tobacco, which has been grown for years. And the National Agriculture Policy of 2016 in Malawi encourages growth of groundnuts as an alternative, and it has been ranked as the second legume, which can cost up to $1 per kg. And botanical classification shows that there are three major types of groundnut, that is Spanish, Virginia, and Valencia. But in Malawi, we only grow Spanish and Virginia mainly. Apart from income benefits, integration of groundnuts in farming systems improves soil fertility through its biological activity, its fixation of nitrogen in plant tissues, which can be incorporated into soils to amend soil fertility. But in Malawi, there are cases of low yields for most farmers, though high yields of 2,000 to even more than that can be attained. But Malawi mainly in smallholder farmers, there are low yields less than 800 kgs per hectare, and even less than 500 can be obtained. And major determinants of groundnuts yields include groundnut varieties and also the agronomic practices that are being followed. Groundnut varieties do not only influence nitrogen, not only yield, but also they affect amount of nitrogen that can be fixed. And it is possible to increase amount of nitrogen from 12 to 30 kgs per hectare. Next. The major issue in Malawi groundnut production is low yields, and which are usually attributed due to low soil fertility. This problem is mainly due to lack of inputs, and most farmers don't apply a lot of inputs like inorganic fertilizers and inoculants and even pesticides, which lead to low yields in Malawi. So this problem has been researched whereby use of various inputs like fertilizers, inorganic fertilizers, their implementation increase yields, and not only yield and yield component, but also the biological nitrogen fixation. So it's a great deal to look into this thing of supplying inputs in order to increase the ability, in order to increase the use and also the benefit, the nitrogen benefit we can get from the groundnut crop. Next. Yeah, phosphorus fertilizers as one of the inorganic fertilizers. It has also been reported by Dramel and Yakuba to increase nodule number and nitrogen fixation. And not only that, different Kasarua and Mambwe in 2040 also noted that application of D compound increased groundnut yield in addition to applying gypsum. And other factors, not only the fertility component, but also plant densities, which is the plant population, also affect the use that we get from the field of groundnuts. And this study mainly has been designed to evaluate how various inputs affect groundnut productivity in terms of yield, biological nitrogen fixation, and its associated costs. Next. Yeah, the main objective is to evaluate, as I've already said, to evaluate effects of plant density and Rhizobia seed inoculation and inorganic fertilizer application performance of groundnuts activities, but specifically to evaluate effects of inorganic fertilizer application, Rhizobia seed inoculation, plant density, and yield components on groundnuts varieties. These varieties include CG9 and Chitala. And another specific objective is to evaluate effects of inorganic fertilizer application, Rhizobia seed inoculation, and plant density on nodulation and biological nitrogen fixation. Next. And the research hypothesis. Firstly, we are hypothesizing that application of inorganic fertilizer and Rhizobia seed inoculation increases the yield components in both Chitala and CG9 groundnut varieties. And also application of inorganic fertilizer application and Rhizobia seed inoculation to groundnuts at high density increases biological nitrogen fixation, that is, as compared to low plant density. Next. This study was conducted at 2 sites, at Central Malawi, at Horizon site and Chiteze site. This was done in 2 seasons, 2019-2020 season and the 2020 to 2021 growing season. And those are the sites shown from serial imagery and also amount of rainfall that these 2 sites received. Next. In each year, from the 2 sites, I collected the baseline soil characteristics. And the soils were sandy loam soils, which are ideal for groundnuts, and the pH was at least normal, that is neutral to neutral conditions, and with medium organic matter and low to very low N and low to medium amount of P. Next. The treatment had 4 factors. These 4 factors included inoculation levels and inorganic fertilizer application, groundnut varieties, plant density. The inoculation levels, I had 2 levels. One was inoculated and the other was not inoculated. And inorganic fertilizer, I used a blend type of fertilizer where the different levels of N and P and other micronutrients. And that blend was applied at 2 levels, yes or no levels. And the groundnut variety CG9, which is a Virginia type, and Chitala, which is a Spanish type. I use these 2 just to differentiate how different types of groundnuts will respond. And plant densities high and low. And these treatments have been clearly explained in the next slide. Next. Yeah, that's just a clear description of what I was saying. Next. That's still the same treatments further explained. These all treatments were laid in split plot design and the randomization scheme for RCBD. Next. the parameters that are collected from soil to crop parameters as shown in the slide. Next. This is another component that are used when estimating amount of nitrogen that was gained from the groundnuts. I used a modified nitrogen difference method where I calculated amount of N from the groundnut and a reference crop, and adding that to amount of N from the soil or from the groundnut soil and from the reference crop soil. There is a reference crop soil. The reference crop plant was maize, and that maize was used to quantify amount of N gained by the groundnut and the maize crop, and the difference that gave amount of N that was gained through the cropping seasons. Next, analysis of data was done in GenStat, that is 19th edition, and ANOVA was used to determine whether there was significant differences or not, and Tukey test was used to separate the means. And data transformations were employed in those data parameters that were supposed to be data transformations, like nodule number and weights. Yeah. Next, that's results and discussions from days taken to 50% flowering and pegging data parameters. And it has been observed that from this experiment that there was there was a difference, and days taken for the groundnuts to flower. There was an interaction between plant density and the variety. That is, each variety were subjected to perform differently in amount of days taken to flower. That is Chitala variety flower less at low plant density and took a long time at a higher plant density. That is, this can be due to plant competitions at a high density. So this perpetuated the amount of time for the Chitala variety to flower, as it had less nutrition. But on days taken to 50% pegging, the results were due to variety. This is mainly due to genetical effect, as it is caused by the groundnut variety. Next.
We'll have 2 more minutes left in the presentation. Thank you.
All right. In that picture, just showing the effect of various treatments on the nodulation and on nodule numbers and nodule colors, and different varieties were affected differently. And next. Yeah, and on grain yield, the grain yield the effects were due to variety and fertility. Next. And on total N, the effects were due to nitrogen, were due to inorganic fertilizer variety, and also inorganic, and also inoculation levels. Next. That's the key messages that I can briefly sum up. That application of inorganic fertilizer increases yield. Application of Rhizobia inoculant increases grain yield in Chitala variety and not in CG9 in response to inorganic inoculant application. There was an interaction in just the previous slide. on BNF. And so inorganic fertilizer application increases BNF. CG9 fixed more N than Chitala. Those were the key messages. Yeah, thank you. Next slide. Thanks to these organizations for sponsoring the project, and also my project supervisors for the big work, good work that they have done towards this research and towards my studies. And thank you for your time. Thank you.